In homework 4.2, we're dealing with absolute value functions and piecewise defined functions. I'll help you with a couple of them. Let's look at this one. This is 2 absolute value of x plus 3. It's just to graph it and write it as a piecewise function composed of 2 linear parts. This is a transformation to the left by 3. That's where the vertex will be. And it's vertically stretched by a factor of 2. So this is the function we have. So we should be able to graph absolute value functions. That was the first part. Now we need to write it as a piecewise function. So we want to write this as a piecewise function. Piecewise functions start with braces, and we're going to say what the 2 parts are. We start with the left part first, and this is the trickier part to do. What we're going to do is we need to say what the equation of this line is and where it lives, what its domain is. Well, the equation of this line, it's a linear function. So an easy way to write the equation is to continue this function until it hits the y-intercept, because then we can use slope-intercept form. Y equals mx plus b. So y equals, this function, the slope of this linear function is negative 2. So it's negative 2x minus 6, because that's where the y-intercept is. This would be y equals negative 2x minus 6. But this line doesn't continue forever. It has a limited domain. So we say y equals negative 2x minus 6 is this portion right here, but only when x is less than or equal to negative 3. We're saying if x is to the left of negative 3, we're going to use this portion. However, if x is to the right of negative 3, we need to use this portion. And this function is another linear function. Here the slope is positive because the function is increasing. So the slope is positive. It's 2x, and the y-intercept is 6. So 2x plus 6 when x is greater than negative 3. We're saying that it's going to be this negative sloped one when x is to the left of negative 3, and this positive sloped one when x is to the right of 3. That's what this says. I'll show you a couple other things with this. It also could have been appropriate to, if you'd wanted to, this is kind of an advanced thing. If you feel good about that first part, you can ignore this. We could have written this as a transformation of the parent function by using any one of these points on this line. So instead of having to go find the y-intercept, we could have said, you know what, this point this can be considered a transformation of the parent function. I could pick any point, but let's say I chose this one, negative 5, 4. I could say this is y equals negative 2 times x plus 5 plus 4 when x is less than or equal to negative 3. The reason this is the same as this is we're using the transformation form. We're saying, hey, this point, if we think of this as normally 0, 0, it get transformed 5 to the left, which is where that plus 5 came from, and 4 up, that's where the plus 4 came from, and this is a slightly easier way to do it so that we don't have to continue it to find the y-intercept. And then the other part would be the same as we had it before. Let's see. This part, I'm not going to answer all of it for you, but it says when x is negative 2, what is f of x equal to? So when x is negative 2, we need to see which part of the function we're on. This function is made up of 2 parts. It's y equals 3x if x is less than 1. It's y equals x squared if x is more than 1. So if x is negative 2, x is less than 1. And so we'll use this top part. So f of negative 2 is going to equal 3 times negative 2. And we knew to use that top part because the x is less than 1. If the x had been more than 1, we would have used the bottom part. So when x is negative 2, f of x is equal to negative 6. On the back, this time it asks you to graph a piecewise function. And I will graph, I'll do b. Y equals negative 3x plus 6 when x is less than or equal to 3, and y equals 3x minus 6 when x is greater than 3. So 3 is where it's going to switch what's going on. And when you're to the left of 3, we're going to use negative 3x plus 6. that has a slope of -3 and a y-intercept of 6. So the slope is down by 3, over by 1, down by 3, over by 1, down by 3, over by 1. So here we are. Note that this one was less than or equal to, so I went ahead and put the point right there. There is a point at x equals 3. The next function is y equals 3x minus 6 when x is greater than 3. So this is when x is to the right of 3. So the y-intercept and all the parts that are to the left of 3 will not be on this graph. So I'm going to just go ahead and use kind of my pen here to see where it would have been. -6 is right here. The slope is +3, +3. This is how it looks. However, it's only going to be this function when x is to the right of 3. So all these points that are to the left of 3 don't count. It starts right here. Notice that it didn't meet up. If this had been less than or equal to 2 and greater than or equal to 2, the function would have made a v right here, and it would have been an absolute value function. We could write the equation. However, this function is not an absolute value function because it doesn't line up. So there is no absolute value equation. The rest I'll leave as a challenge to you. I hope you guys do a great job on your homework, and I hope this helped.